Hi, in this video what I'm going to do is go over the basic definitions in maxima and minima and mention a couple of theorems and also go over some examples. Okay, so let's start with this graph of the function y equals f of x on the closed interval negative 14 to 14. Okay, so here you have it, the graph of it. And what I have done here is I have marked the endpoint, this point over here, which looks like it's a maximum point near all the points near negative 10, at all the points near negative 10. Then I've marked this point negative 1. Same, it looks like the function value is the smallest in a small little interval around negative 1. I've marked 5. Same thing over there. And I've marked the other endpoint 14. Okay? So looking at this picture, you know from this that the largest value of the function on this interval occurs at 5, right? So 5 is called the absolute maxima. And when does the smallest value occur? Well, the smallest value, if you look at the whole graph, you see it occurs at 14. Well, so what we have is 5 is called the absolute maxima, 14 is called the absolute minima. Okay, and over here negative 10, because it's the largest in a small little interval around negative 10, is called a local maximum, and x equals negative 1 is a local minimum. Also x equals 5 is a local maximum, okay, because it's the largest in a small little interval around. Okay, so let's just mark it. This is a local max. This is a local min. This is a local max. And it's an absolute max. And this is an absolute min. Okay, so when you talk about a continuous function, actually any function on a closed interval, you could potentially have an absolute maximum and an absolute minimum. If the function's continuous, in fact, you will have one. Okay, but you could look at graphs of different functions, and there's different examples where you will see there might be a max, there might not be a max, and so on. All right. So here's another example. If you look, okay, now let's take this. And what I'm going to do is, let's say I just define the function from negative 4 to 4. Okay, and let's make it 2 at negative 4 and is going to 6 at negative 2, but it's an open circle at negative 2. In fact, let's make it 4, and let's suppose it's constant, and from here let's say to have this. Okay, so for this function, what do you notice? What is the absolute min? This will be the absolute minimum. Okay, and what about an absolute max? There is no absolute max, because you could say, well, here you can't say the absolute max is 6, because for no x value in the interval -4 to 4 is f of x equal to 6. You can take 5.999. Yeah, there's an x that f of x equals 5.999, but then there's also 5.99999, and so on. So if you look at this graph, and you can say G has no absolute max, and then G has an absolute min at x equals 4. Okay, makes sense? Okay, so let's just look at a few definitions. When you look at the domain of a function, you call C an interior point if it's on the inside, basically. So there's an interval around C that is completely contained in the domain of F. So for example, let's take a look at, suppose you have that the domain of F is the interval 1, 2, 3. Okay, then 1 is not an interior point, even though 1 is in the domain of F. And x equals 3 is not in the domain of F, and nor is it an interior point. But anything between 1 and 3 is an interior point. Okay, so just showing, it literally is what it is, indicative of by the word interior. So if you take any other x equals 1.0001, that's an interior point. Okay? Okay, next we have a critical point. What's a critical point? For a function f, you call a point a critical point if it's an interior point. So that's an important clause that you look for. It has to be an interior point, and the derivative is 0 or the derivative is undefined. So you do need that the point C is in the domain of F and it's an interior point. So C must be in the domain of F and an interior point. Okay, and then you call C a critical point. Okay, and then when you have a function, a point will be a local extremum. So like we saw over there, -10 or -1 or 5, these are all local extremum. If the function is differentiable at the point, then a function has a local extremum and f has a local extremum, then it must be that the derivative is 0. So what is it saying? If the function is differentiable and f has a local extremum at the point C, then it must be that the derivative is 0. So you see it has a local extremum there and the derivative is 0 because the function is differentiable at -10. How about at -1? It has a local minimum. It's differentiable, so the derivative is 0. How about at 5, the functions got local maximum at 5, but the function's not differentiable. You know, you can see that the slopes, when you look at the limit as h goes to 0 of f(x) plus h over h, from the left and the right, you will have that the slopes don't match up and the function's not even differentiable. So that doesn't apply here. It just says that if the function's differentiable and there's a local extrema, it must be that the derivative is 0. Okay, so that's just a little theorem that you have. Okay, so what we want to look for is we want to look for the critical points in order to then later we'll see how to figure out if they're local maxes or mins. But it's in fact easier to see if a point is an absolute max or min on an interval. Okay, so first we want to see if you have a function, how do we find its critical points? So what do? You find the derivative of the function and all the interior points in the domain of f where the derivative is 0 or undefined, then you have that the point is a critical point. Okay, so it's important that you have interior point in the domain of f and f is undefined or f is 0. So that's important. Okay, and I just wanted to make sure that you got that f is defined at c and that it's an interior point. Okay, so these are just critical points. They form candidates for your local extrema. All right? Okay, so let's see examples of critical points. Okay, so let's look at this one. The first one we have over here, it's a function y equals f of x. You see the point x equals c1. The function's differentiable there, and the derivative is 0, so it's a critical point, and in fact, it's a local max. Okay, let's look at this next one. Y equals g of x. Well, the point x equals c2, what do you have? The derivative is undefined at that point, and you have that x equals c2 is a local max. But regardless of whether or not it's a local max, you do know that the derivative is undefined over there, and it is an interior point of the domain. So the function's also defined at c2. So you have that c2 is a critical points. Okay, let's take a look at this. Over here, you have that h prime of c3 for the function y equals h of x. The derivative is not defined at c3. It's over here, the derivative is infinite. Over here, the derivative is not defined because you can very clearly see the slopes are different, and you have that the function has a local min. Okay, now let's take a look at this one. Over here, what do you have? The derivative is 0 for this fourth function. We have y equals j of x. The derivative is 0 at c2 and define c4, and c4 is an interior point, but it's not a local max or a local min. So you have a critical point which is not a local max or min. All of these are critical points. C1 for F, C2 for G, C3 for H, and C4 for J, C5 for K. But we're seeing that it could just be that you have a critical point that's a local max or a min, and the critical point could be where the derivative is 0 or undefined, and it could be that the derivative is 0, it's a critical point, but it's not a local max or a local min. So over here you have that the derivative is 0, but it's not a local max or min. And the last one, y equals k of x, you have that the derivative is undefined at C5. You can see it's vertical, but it's not a local max or min, okay? So you see, you don't have that all critical points are local extrema. So here we have examples of critical points being an extrema or not, okay? So let's first look at some examples where we're looking for critical points, okay? So first let's look at these. Let's do example 1. So you have y equals x squared minus 1 cubed. Okay, y or f of x, whatever you want to call it. Okay, so first let's take a look. Is there any restriction on the domain? No. What is the domain? The domain is negative infinity to infinity. Okay, all right. Now, what is y prime? We have to use the chain rule. It'll be 3x squared minus 1 squared times 2x. Okay, so 6x times x squared minus 1 whole squared. Okay, so for critical points, what do we have to do? We find when is y prime 0. Okay. So to find the critical points, you set y to 0, or you find out where y prime is not defined. Okay, so in this case, of course, y prime is defined because it's 6x times x squared minus 1 squared. For all x's, this is defined. So in this situation, you can say it's defined everywhere. And then let's find out when is it 0. You have that 6x times x squared minus 1 squared is 0. Okay, so when does that happen? Either 6x is 0 or x squared minus 1 whole squared is 0. Okay, so let's see. You have that. I'm going to continue it right here. 6x times x squared minus 1 whole squared is 0. So 6x equals 0, so x equals 0. Okay, or x squared minus 1 whole squared is 0. Okay, now when is the square of a number 0? When the number is when the number is 0. You don't need to put plus or minus because it's 0. Okay, when is x squared minus 1 0? That will be when x squared equals 1. So x is plus or minus 1. Okay, well, let's just check. X equals 0, the function's defined. X equals plus or minus 1, the function's defined. So in this case, the critical points, putting all this stuff together, so critical points are x equals negative 1, 0, and 1. Okay? All right. So now let's do another example. All right, the second one says y equals 4 square root x minus x squared. Okay, so let's just pay attention. What is the domain of this function? The domain is x bigger than or equal to 0. So if you want, we'll write it like this. Okay. Make sense? Okay, so now so looking at this interval, you see 0 is not an interior point, or any positive number is an interior point. Okay, anyway, so now let's find the critical point. So for that, first we need to differentiate. So x to the 1/2, it'll be 1/2 x to the negative 1/2 minus 2x. Okay, so what is it? 2 over square root x minus 2x. Okay, so what are the critical points? The critical points are interior points where y prime is 0 or undefined. So let's take a look. You have that y prime is undefined when you have that there's a division by 0, so square root x is 0, so that x equals 0, right? Okay, but is x a critical point? X equals 0 a critical point, but x equals 0 is not an interior point of the domain. So x equals 0 is not a critical point. Make sense? You need it to be an interior point. Okay, so that didn't yield any critical points. So now let's see when y prime is 0. So you can factor out the 2 if you want. So you get 2, 1 over square root x minus x equals 0. So that is 1 over square root x minus x is 0. And you know x is not 0 because that's not an interior point. So solving this, what do you have? 1 minus x raised to 3/2 multiplying over square root x is 0. Okay, when is this going to be 0? When the numerator is 0. So that's 1 minus x raised to 3/2 is 0. So 1 equals x raised to 3/2. Okay, so you first square rooting and then cubing, or first cubing then square rooting, but it doesn't matter. In either case, you would need x to be positive, and this means that x equals 1. Okay? And no other x value will give you y prime equals 0. Okay, so the critical points are, they're just x equals 1. The only one, we do have to check, is x equals 1 an interior point of the domain? And yes, it is, because the domain is 0 to infinity. Okay? Okay. All right, makes sense. And now let's look at the last example. And that is x squared minus 4 over x squared plus x minus 6. Let's do this. Okay, so first let's take a look at what the domain is. So for that, first let's factor this up. You have the difference of squares in the numerator, so you have x plus 2 times x minus 2 divided by x plus 3 times x minus 3. Oops, sorry, not minus 3, minus 2. Okay, so just looking at this, you know what is the domain? The domain will be x not equal to negative 3 and x not equal to 2, right? Even though you can cancel x minus 2, but still x equals 2 is not in the domain because it's in the denominator. There's a whole discontinuity at that point. But in any case, for finding the derivative, it'll be simpler to actually just cancel these terms. There's a hole here. Okay. All right, and there'll be an asymptote there. Anyway, we'll look more at that kind of thing. Vertical asymptote over there. Okay, so if you want, let's just write down the domain in a better way. Negative infinity to negative 3, union negative 3 to 2, union 2 to infinity. Okay, so that's the domain. All right, so now that we have written y like that, let's look at what is y prime. It's f over g, right? So, or u over v, so you have that 1 times x plus 3 minus x plus 2 times the derivative of x plus 3 over x plus 3 whole squared. So if you work this out, this turns out to be x plus 3 minus x minus 2. So it's just 1 over x plus 3 whole squared. Okay. So now we can see y prime is 0 never. And y prime is undefined when x equals negative 3. However, this is not a critical point as x equals negative 3 is not in the domain of an interior point in the domain of f. In fact, this is not even in the domain of f. Of y, of function. Okay, so there's no critical points. Okay, I hope that makes sense. And we did do a little bit of trickery over here to find the derivative nicely and not have to deal with a complex expression wherein things would cancel and simplify to 1 over x plus 3 squared anyways in the denominator. Yeah, okay. All right. So a few more things now. We look at absolute maxes and mins. Suppose you have a function, maybe on an interval or maybe on the whole real line or half of an infinite interval or whatever. Suppose I want you to find the absolute maxes and mins of a function on a closed interval. Okay, what do you have to do? How do you do that? Well, the absolute maxes and mins will occur when at x's that are critical points or at the endpoints. So what do? You will find all the critical points of the function and you will evaluate f at those critical points and also evaluate f at the endpoints, and whichever is the very largest will be your absolute max, whichever is the very smallest, that x will be your absolute min. Okay? So you find the absolute maxes and mins by first finding the critical points, and you find the function value at all critical points and the endpoints, then compare them. The x that gives you the maximum is the absolute maximum, and the x that gives you the minimum is the absolute minimum. Okay, lastly, just a little mention of this extreme value theorem. So what is this saying? It's saying that if you have a function that's continuous on a closed bounded interval, if you have an infinite interval, it won't work. But if you have a closed bounded interval, then there has to be a point in that interval where the function's the absolute minimum and where the function's an absolute maximum. Now, you do need that it's closed and bounded. So here, for example, I'll just mention that you need closed and bounded. Example, f of x equals x squared on the interval 0 to infinity. Okay, this is closed on one side, the other side's infinity, and this function's unbounded, you know, right? This function's like this. Okay, so f is unbounded, and it doesn't have a max on the interval. No absolute max. Okay, the interval is not a bounded interval. Okay, so just saying that you do need those conditions. Okay, so but if you have a continuous function, then you do have an absolute maximum and an absolute minimum of the function. Okay, so now let's try this one right here. Okay, so suppose you have this function x squared plus 2 over x, and you're asked to find the absolute maximum and minimum of this function on the interval 1 to 4. Well, it's all fine on 1 to 4. There's no problem. F only has a problem at 0, but otherwise everything is fine, and 0 is not in the interval, so we're good. So how do we do this? It says, first I said, find all the critical points. So let's find the critical points by differentiating. Okay, and that's what you get if you want. Let's simplify it. Okay, and what are the critical points? Either where f prime is undefined or where f prime is 0. Well, f prime's only undefined at x equals 0, but x equals 0 is not even in the domain, right? So f prime defined on the whole domain that you're considering, f prime equals 0 when x minus 1 over x squared is 0. Okay, simplify that and you have multiplied by x squared, if you will. Let's just squeeze it in there. Show it in a different color so you can see what we're doing. Okay, and so what do you have? You'll have x cubed minus 1 equals 0. You can cancel the x squared because 0 is not in the domain, so x is not 0. So this means that x cubed is 1 and x equals 1. Okay, so what are the critical points? Well, you found x equals 1. Okay. Well, is that a critical point for this function? Well, you have that x equals 1 not a critical point for f on the interval 1 to 4, as x equals 1 is not an interior point, okay? All right, I hope that makes sense. And then you're done. And f has no other critical points. F has no critical points. Okay, all right, so now let's look at this next example. Find the absolute maxima and Oh, sorry, we were not just looking for critical points in the problem, we're looking for absolute maxes and min. So what do? Okay, so f has no critical points, so that part was done. Then what was the second part we had to do? We had to find the values of the function on at the endpoint. So we had to find the values of the function at the critical points and the values at of the function at the endpoints. So let's find what is f of 1. It is 1 plus 2 over 1, which is 3. And we have to find what is f of 4. It is 4 squared plus 2 over 4, and that is 16.5. Okay, so then you have that at x equals 1, there's an absolute min. And then at x equals 4, there's an absolute max. So basically, in the end, what you had to do is look at all the values of the function at the critical points as well as the endpoints, and then compare them. Whatever's the very biggest is the absolute max, and whatever the very smallest is the absolute min. Okay? All right, next question. I want you to find the absolute maxima and minima of this over that interval. Okay, so let's take a look firstly at this. And we'll use orange. Okay, so look at that. You have f of x is 5x to the 1/3 minus x raised to 5/3. And because it's odd root, 1/3 and 5/3, you can define it for all x values. You don't need x to be positive. So this function actually is defined everywhere. So domain is all of this. There's no trouble points in there. Okay, but anyway, you're given f on that. So now let's look for f prime. Okay, so you have 5 times 1/3 x raised to negative 2/3 minus 5/3. Okay, and then you have x raised to 5/3 minus 1, which is 2/3. Okay, so just factor out the 5/3, and you have 1 over x raised to 2/3 minus x raised to 2/3. Okay, all right, so now let's find the critical points. Okay, critical points are where f prime is undefined. When is f prime undefined? If you take a look, this is undefined when x equals 0, and x equals 0 is an interior point of domain of f. So x equals 0 is a critical point. Okay, now let's take a look. F prime equals 0 when you have 5 over 3, 1 over x raised to 2/3 minus x raised to 2/3 is 0. Okay. So when does that happen? Let's take a look. Of course, the 5/3, that can just cancel, and you have 1 over x raised to 2/3 minus x raised to 2/3 is 0. So 1 over x raised to 2/3 equals x raised to 2/3. And when x is not 0, x equals 0 is already a critical point. We've already separated that. When x is not equal to 0, you can multiply throughout by x raised to 2/3. And what do you get? You'll get 1 equals x raised to 2/3 plus 2/3, which is 4/3. Okay, now, when is 1 equal to x raised to 4 thirds? Well, let's just take a look. Well, when x equals 1, x raised to 4 thirds is 1. So that's good. When x equals negative 1, x raised to 4 thirds, what is that? You have, let's see, negative 1 raised to 4 thirds. What do you have? Raise it to 4 and you'll have 1 cubed, and that's just 1, so that works. Okay, and are 1 and negative 1 parts of the domain of f? No, 1 isn't, so this is out of domain because we're only looking at negative 2 to 1/8, and x equals negative 1 works. So far, what do we have? The critical points are x equals 0 and x is equal to negative 1. Okay, so that was the first part. Find the critical points that are an interior, find the critical points. By definition, they're interior points. Okay, the second part is find the function value at the endpoints and the critical points. Okay, so the endpoints are x equals negative 2 and x equals 1/8. Okay, so we'll find f of negative 2. Well, let's see, what is the function? 5x raised to 1/3 minus x raised to 5/3. All right, well, let's see. What will it be? 5, and you'll have negative 2 raised to 1/3 minus negative 2 raised to 5/3. Okay, so it's just the cube root will just give you minus 5 times the cube root of 2 minus raised to 5 will give you minus, and minus will stay minus, so it'll become plus 2 raised to 5 will be 4, 16, 32. 32 and the cube root of 32. Or if you want, let's just write it like that. Okay. All right. And if you want, just take a look at this. What will this be? If you look at 5, 5 is the cube root of 125. So this whole thing will be the cube root of 250. Plus with a minus there. Okay, just writing it so in case you need that to compare the values, but you can see. Okay, then we have to check f of 1/8. Let's do that. 5 times 1/8 raised to 1/3 minus 1/8 raised to 5/3. Okay, this is much nicer. What is the cube root of 1/8? That will be 1/2. And what is 1/8 raised to 5/3? First, you can take the cube root and you'll get 1/2 and then raise it to 5. So, whoops. So if you want, you can write it down. Multiply 5 by 16, 80, 79 over 32. Okay, and the f of 0, what is that? That is just 0. f of negative 1, let's figure that out. You have 5 times negative 1 raised to 1/3 minus negative 1 raised to 5/3. Okay, this is just going to be minus 5 minus, and this is just going to be negative 1. So that is negative 4. Okay, so let's take a look. And we'll see that you have, we need to analyze this. You have at 0, the function 0. At negative 1, it is negative 4. Then at 1/8, it is 79/32. So that's larger than all of these so far. And of course, that's a negative number. So we do know from this that that will be the maximum. So absolute max when x equals 1/8, and the max value is 79/32. Now it turned out that these numbers were like this. You wouldn't get numbers like this on a test. So you have the cube root of 250 minus the cube root of 32. Well, what is the cube root of 250 going to be? Well, you know it is smaller than, so let's see, 6 times 6 times 6 is 36 times 6, so that's 216. Okay, and so this is something between negative 6 and negative 7. How about the cube root of 32? Well, let's see, 3 times 3 times 3, so this is between 3 and 4. So we just have to actually take a second and calculate it, and figure out what is the absolute max, and what's the absolute min, whether this is, that's between 3 and 4. So this negative 1 will be the absolute min. Yeah, okay, min value is negative 4. Okay. Yeah, these numbers, I just had to do some little thinking to figure out what it is because I'm not using a calculator. Okay. The last question we have is the absolute maxima and minima of this function on the interval negative to 1. Okay. So let's look. All right. Okay. Well, this function's weird. It's got this absolute value, and it's a cube root. It's defined everywhere, so the domain is all of this negative 2 to 1. There's no problem points. So let's just first write f of x down properly. It's the cube root of x if x is positive, and it's cube root of x if x is negative. You get a negative number. The absolute value will have a minus. Okay, all right. So let's look at what the derivative is. Well, the derivative would be, so x raised to 1/3, it'll be 1/3 x raised to 2/3 in the denominator. If it's positive, I cannot include 0 because 0 is on the boundary of that interval, okay? And x less than 0, there's a minus, but it's the same derivative with the minus, okay? So what happens at 0? If you look, this thing goes to infinity as x goes to 0. And how about this x is negative, okay? And if you take the cube root and square it, this gets very, 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 very small. So this goes after negative infinity. But in either case, what happens is the tangent line gets more and more vertical, okay? So what do you have? You have that f prime x is undefined at x equals 0. And x equals 0 is an interior point of domain. So x equals 0 is a critical point. And how do you find the absolute maxes and mins? You have to evaluate the function at the critical points and at the endpoints. So let's find out f of 0, that's 0. Okay, let's do x equals 2. What do you have to do? Negative 2, sorry. You have to take the cube root of negative 2 and take its absolute value. Okay, that's the same as cube root of 2, you know. And then x equals 1. You have to take the cube root of 1 and then you just get 1. Okay, so looking at this, you know this will be the absolute min and this will be the absolute max. So x equals 0 gives you the absolute min with min value 0, and x equals negative 2 gives you the absolute max with max value cube root of 2. Okay, and you can graph these functions and take a look what they look like. Let's just quickly draw this one. What this is a cube root looks like this, but I've taken the absolute value. So instead of this part going down here, you get rid of that bottom part and it will in fact be on the top. Like that, okay? So the function is this, and this, and you're going from negative 2 to 1. Oh, I didn't do the best job of drawing it. Yeah, there, that's much better. Okay, and the domain you have is negative 2 to 1. And from this you can see, when you just restrict your attention to this part, you can see that you have that the absolute max occurs there and the absolute min occurs there. Okay, well, I hope this was helpful. Turned out to be a longer video than I intended, but you know, hopefully you can speed it up, and you have sped it up in parts that were slow for you, or rewatch parts that were
complicated. I'll also post these notes. All right, guys. Bye.